Hello, welcome to my channel. In this video, we want to find the antiderivative of tangent of the inverse sine of e raised to the power of x. Okay, and we put the dx over there. Now, this question is going to be really interesting, and if it is, please do well to subscribe to my channel. Now, let's start off by observe that tangent of thing, right? We usually have tangent of an angle, so that means this here must be an angle, inverse sine of e raised to the power of x. And what if we call that theta, the angle, right? We say let theta be inverse sine of e raised to the power of x. That means this is going to become the integral of tangent of theta, right? And then we put the dx over here. Okay, this is not a good state, in a good state to differentiate, because this is x and this is theta. Theta has a connection with x, so theta is not a constant, so this is not a good way, a good place to start integrating, right? So we still need to do some work here. So since theta is said to be sine inverse of e raised to the power of x, if you apply sine on both sides, we are going to have sine of theta to be e raised to the power of x, okay? Now observe that if we have this on a right angle triangle, where this is the angle theta, and then this is 90 degrees, right? Which tells us that this is the hypotenuse side. Sin theta is e raised to the power of x. That means sin theta opposite is e raised to the power of x, and then the hypotenuse side is 1. You know, sine of an angle is opposite over hypotenuse. This is e raised to the power of x. This must be e raised to the power of x divided by 1. So that's where we get the hypotenuse from. And that tells us that the adjacent side will be, well, the square of the hypotenuse side minus the square of the opposite to the angle. So when we take the square root of the square of the hypotenuse minus the square of the other side, all right, it will give us the adjacent. So this is 1 minus e raised to the power of 2x, okay? So that means that from there we're going to have, you observe this is tangent of theta. So this is the angle theta. Tangent is opposite over adjacent. That means we are going to have e raised to the power of x divided by adjacent, which is just the square root of 1 minus e raised to the power of 2x, right? And then we can put the dx here. So this makes sense. This makes sense because this is a function in terms of x, and we are integrating it over the x variable. So we can go on, okay? Unlike what we had in the previous step. Observe what we have here. I would like to do a little u sub. I'll say let u be e raised to the power of x. And the reason is, you know, we have the square root of 1 minus e raised to the power of 2x. Usually, when we have the square root of a number minus a square of a function of x, right? Let's say a square of, in this case, it is an exponential function. In most cases, we usually have a linear function. We usually make use of sign substitution, right? Okay, so we can do that, but let me just use the u sub first, and we are going to see what I'm talking about. So we have e raised to the power of x should be u, right? That means that we are going to differentiate both sides with respect to x. We are going to have e raised to the power of x dx. The reason is the derivative of e raised to the power of x stays the same, and then we have this to be du. So from here, that means we're going to have this to be the integral of e raised to the power of x is said to be u, right? So in place of e raised to the power of x, I'm going to put u at the top. And then we say that divided by the square root of 1 minus e raised to the power of 2x. Well, since e raised to the power of x is u, e raised to the power of 2x will be u squared, right? Because that's just the square of what we have. And then dx, well, dx is just du over e raised to the power of x, which is u. Because we say e raised to the power of x should be u. So as you can see, this and that will cancel out nicely, and we are going to have the integral, okay? So let me put it well. We are going to have the integral of 1 over the square root of 1 minus u squared. And we put the du over here. This right here is the inverse sine of u. Okay? The integral of 1 over the square root of 1 minus u squared we have, when we differentiate inverse sine of u, we get this integrand 1 over the square root of 1 minus u squared. So the antiderivative will give us the inverse sine of u. And what is u? Well, u is said to be e raised to the power of x. That means we are just going to have the inverse sine of e raised to the power of x, right? And we can add an arbitrary constant, and this right here is the antiderivative of that function. So what did you see? Well, the antiderivative of tangent of sine inverse of e raised to the power of x is sine inverse of e raised to the power of x. So it's as if the tangent didn't even exist, right? Though we added an arbitrary constant. So look at this and look at that. We look at see if we can just cancel this and then cancel that. Okay, anyway, thanks for watching, and if you like this video, please do want to subscribe to my channel.